Okay, Alvaro has entered the building, so please shut the door. Let's see who's back there. Thank you. I know there's been a lot of routing meetings today, a lot of key working groups in routing, and I bet everybody is a little bit fatigued. So I'm not one of those guys who's going to have you stand up and jump around. But if you have to, I'll know the reason. Anyway, just one working group thing before we go. Before the next one, please try and get your requests in early. As you can see, we probably won't use the whole 2 sessions. We're thinking we're going to ask for 2 sessions again, but we'd like to get the request in early. So if it looks like we can easily fit, or we can fit in one, we'll cancel one of them. I don't know how many people are now that we have the flooding infrastructure. I don't know how many people are going to have proposals for flooding algorithms that fit into that infrastructure. And without that, oh yeah, we have the note well again today. I'm sure you've seen it, and if Gunther says, if you haven't seen this already this week and in the last weekend group, you've probably been having too much fun and not attending enough IETF meetings. Is he in here? I don't see him. Anyway, so we'll get started with the presentations we have today, and I think I'm first, right? I got a quick one. Oh yeah, I guess that's something.
So I'm going to move the agenda around a little bit. Sue, are you here? Raise your hand. Oh, there's Sue. Hey, Sue. Yeah. So we're going to move you from the very end to before Tony. So you'll be 3 from the end. So not yet, but middle.
Okay. Okay. I'll be ready whenever you are.
Okay. AC, didn't you just tell me that they don't like you doing that?
They do not like you jumping off there. No.
Oh, I just clicked the wrong button.
Chris was able to figure out the whole secret to the Chromebook clicker.
Not the whole secret. Okay, for any working group chairs out there, apparently sometimes they crash or something, and you have to power cycle them. So off and on.
So how do I get it up in the first place? Just hit it.
First I have to click the button or something.
I do?
Me.
Oh, you do? Okay. I didn't think I could do it. Okay, now that we have the base Yang model is with Alvaro and hopefully to the IESG in a month or so, and hopefully published. We left the OSV-FV3 extended LSA out of the base model because at that time we didn't have any implementations. So already it was a big piece of work in order to for everybody to review, and we just published this last year, the actual functional part of it, had got some implementations. So this year we did a model, but now a lot of the extensions that are coming are going to be based on the extended LSAs, and we're going to need this. Like I said, we published the functional draft for OSPF v3 LSAs, and it's now the next gen IGP of the IETF. There's several implementations. I'm hoping we'll get more implementations of it. And like I think I went through all this, but these are the features that are going to be extended on, going to be dependent on the OSPF v3 extended LSAs. There's 2 requirements. There's some configuration, but the biggest one is all the operational state for the link state database. So here's the, because the configuration is so simple, I included the whole tree for configuration data in here. You can configure support of extended LSAs at either the area or the global level. If you remember the history of extended LSAs, at one time we had all these compatibility modes and everything, and everybody thought those were really ugly, and I thought it was limiting the implementation, so we made it much simpler. Now here's the operational state. In the link state databases, we have the state data for the LSDVs, and we have all the encodings. So for instance, This is the extended router LSA. We have all the TLVs. You see, we have the TLV type, and then we have the parts that are the base type for all the different types of links, and the rest are unknowns. But the other drafts will augment this. Like if you add a link attribute, you'll augment this tree and put the link TLV in, and it will no longer be a unknown sub TLV of the link TLV. And then I just put the network as another example. We have the attached router TLV. One thing I did is I didn't do a per neighbor in the router LSA, because the router LSA has this is more an 8362 consideration. The network LSA has never had per neighbor stuff. It was just like a pseudonode that had the connectivity to all of them. So we don't want to code per neighbor stuff there. And that's all. I'm going to press review and comments. And we're going to socialize this on the LSR list, initiate discussion, and then maybe ask for adoption. The one thing we're not doing is we're not conditioning the LSA types by the scope of the LSA. For instance, we don't limit the link LSA to, the link extended link LSA to the link database. And I think I could do that. The only thing is, if I do that, it wasn't done for the base LSAs in the link state database. But I'm going to have to do that pretty quickly if I want to put this constraint on it. The thing about configuration, the constraints are really important. For operational data, the constraints are, it's what you see is what you get. Really, putting constraints in the model isn't as important. I think I might ask some of the other Yang doctors what they think about this. And that's it.
So AC, do we have this in ISIS? I don't think so, right?
ISIS was always TLV based. This is an extension just to make OSPF v3 TLV based, and it took a long time for us to standardize it because it was not. It's backward compatible. It's not backward compatible, so you have to change.
Right. No, but so you're exposing the LSA, the TLV types and data and all that through Yang here.
Yes.
Right. Do we have that elsewhere? I mean, I'm not saying.
Yes, we do. We have it in the link state database in LSP.
Yeah, I didn't see.
Stefan went through very meticulously, and I reviewed them all.
Okay.
They're in ISIS too. Yes.
Yeah, I'll look again.
Yeah. I mean, it's a huge.
Yeah.
I mean, those drafts for the models are, I think they're 120 pages apiece.
It also brings forward. I mean, basically every TLV that you add now, right, needs to augment its little TLV in. So
at some point, I think you can batch them, because if you look, oh shoot, I didn't need to do that. Oh, it's good, it's working. If you look, the ones that aren't defined are displayed as unknown in the operational state. So if you
you can still get to them.
Yeah, if you do a RPC.
Right, but so as a sort of a process thing that I'm getting at, if we're going to have the LSP and LSAs, right, exposed like this, we might want to just say, if you have a TLV, you need to augment the model.
Oh, I see. You mean in that draft for that
exactly.
function.
They need to be
We've talked, actually, Stefan talked to me. It could be painful to do it one at a time like that, and batching them might be easier. But yeah, we could do that. I saw a VFD draft, which was really nice. Oh, you're going to tell it. Go ahead. That's your comment, right?
Well, no, I'm not going to talk about BFD. I think that model of doing templates is actually inappropriate here. Yeah. I do recommend having examples of how to do the extension. My question or point was going to be, for the unknowns, it's important to state in here that for things you do know about, you should subtract them from the unknown set.
Exactly, yes.
Right, so it's interesting, and I haven't given this enough thought. We'll have to do this later, but what happens when it's no longer unknown through an augmentation?
Exactly.
This is Yingzhen. I think if you define a new feature with a new TLV, and then if you put it as a requirement to add a Yang model augmentation in every draft, then we may end up with too many small modules. So that's the, but it's easier to keep track this way. So there are some good things and some bad things about it. If you choose batch a bunch of TLVs together, then we may have a cleaner look of all the young models altogether. But then you need to keep track of everything. Okay. So it's I think it's a working group decision how we want to proceed.
Sure. So to summarize it, you're worried about module namespace pollution.
Right. So we end up with like 100 small modules.
Well, we have 100 RFCs doing TLVs. That's already pollution, right? So but I don't mind polluting Yang a little bit.
They all come in when the Yang catalog with their revision dates and everything. So it could get out of hand if you think every working group having 100.
I think that if you get to modify the base protocol with the TLV, that we don't have to worry about how we're affecting the silly module.
Okay. Yeah.
Yeah, Jeff. So your first round of things, you should just pick what the core items are and put them in there. This is the same thing that we have in the BGP model. BGP's base RFC is very tiny, very easy to manage. And the Yang model that we have is covering a dozen technically optional features. And they're not protected by if feature statements or anything else like that. It's perfectly reasonable to say these are, and you have to figure out from a working group what that means, but figure out what the common extensions that everybody's likely to support, even if they don't, put it in there and then put in the necessary either feature statements or not to allow them to be optionally present.
We do have features, we don't have them in separate modules, but as far as putting them in separate draft, agreeing, we didn't really agree exactly what the base was. We did take SR out.
Yep.
So I think making it small, I think that router LSA has left the egress port.
Don't try to make it as tiny as possible. Stick all the common things there. Day one makes it easy. Put in the example of how things extend. It's like if this.
I guess some examples of how you do it. That's a good idea. And augment
And just as a similar example, if this module is containing an unknown TLV, here's what it looks like in the unknown statement, and when it gets implemented, here's how it shows up.
Yeah. Okay.
So I'm still not sure that we have a resolution to the unknowns when they become known through augmentation.
I'll put that in the description of this.
How to do it, right?
Put that anybody who has an augmented, as new features, I'll put it in the description. I don't think there's any way to represent it because this is not what you're sending; it's what you're getting. It's read-only state. So,
but the point is that so is it in unknown and known at the same time because the augmentation happens in a separate module, right? We can take this offline because it's basically not Yang stuff.
It is, yes.
But it's sort of opened up an interesting. I don't even know how to deal with it.
Okay, that was a good comment because it's clear to me how it would work, but I don't think it's stated formally like. Has come is clear now. Who's next one? Is it Rand? I think it's Rand. Rand from ZTE. There you are. Are you Rand?
Yeah, I'm Zan.
No, you're next.
You know better than that. It's okay.
A bunch of people sit up, sit down. You don't know who's going to be.
Whoever's standing.
This is Rand's first presentation here.
Yeah.
So we welcome her to the LSR working group.
Yes, thank you. Good afternoon, everyone. I'm Zan from ZTE. Today I will talk about the packet network slicing using segment routing. Yes. Problem statement. Draft TIS enhanced VPN specifies the layered architecture of enhanced VPN. based the layered architecture of enhanced VPN. This document specifies the solution to create virtual network in a packet network. Yes. Introduction, explicit virtual network identification, administrative instance identifier AII to meet the different service in entire network, which is not only in IGP domain, but also in cross-domain case. AII is one of the constraint criteria of the color template, which is defined in the draft of Spring segment routing policy. And the color template with AII provides a more flexible control. Virtual network based on P2P SRBE for best effort service and P2P SRTE for traffic engineered service respectively. Uniform color template include synchronized and distributed inter-domain for overlay service mapping to underlay results. There is no modification to the forwarding table. In order to distinguish the forwarding behaviors, the prefix SID will be allocated for AII. Yeah. This is the solution. There are two virtual network, AII1 and AII2. This is just an example. Based on the color template with AII, it can be calculated three paths. That is SRTE1, SRTE2, and SRBE in the AII1. The resource allocation is based on the link. Yeah. This is only the solution to create virtual network in a packet network. Yes, this is multi-domain deployment. We support, I think it is easy to provide the end-to-end in the domain case, yes. In some deployment, operator adopt BGP-LU for set up the BGP-LU LSP. The overlay service will directly over the BGP-LU LSP. If the overlay service has the requirement of the TE, which defined as the color, the BGP-LU will have also support the color. The BGP-LU labels will be allocated for color. The below is the option B inter area. It can also provide the end-to-end virtual network, including the inter-domain link. The inter-domain link can also choose the path based on the color with AII. Next is the end-to-end SRTE with SDN. The BGP-LU will be used to inform the topology information contains the AII to the controller. Then the controller can calculate the SR path based on the information. Yes, combined with SR flex algorithm, color template with AI could map to the FAID for label stack optimization. When the algorithm value advertised is a FA value, the prefix SID is associated with path calculated using the FA algorithm in the associated topology AI specific. Yes, next step, comments welcome. Thank you.
Hey, Selena, I just, we went back and forth. I read this on the plane and I had a lot, and I said, well, this has a lot of touch points with a lot of different working groups. And I thought maybe it should go to TE, the TE chairs. I talked to Lou and Pavan, and well, at least to Lou personally, and Pavan didn't disagree that it probably we should look at that. The touch point it has here is it's leveraging in the intra-domain case, it's leveraging the flex algorithm. The difference between this one and the enhanced VPN is it does not use a VPN or a VRF. It just does data plane resource usage by using different algorithms and mapping them to different colors. So it's a lower overhead than having a separate VRF per these VNs, right? That we talked about that.
Yes, that's right.
Which is the big difference between what Stuart presented at length a couple IETFs back in the routing working group.
Yes, I will continue this work on the TE's working group.
Yes.
That the advantage of our solutions, I think it is very easier to achieve the in the domain virtual network. Yes.
So this may not be Rand's last presentation LSR, but it could be the last one on this topic. Anyway.
Thank you.
Jay?
Yeah, Jay Dong from Huawei. Yeah, I think we talked offline before. Actually, I think it's good to reference the enhanced VPN framework draft, and I think the mechanism overall is aligned with that one. Another comment is actually this one is more segment routing specific solution, right? And we currently have a segment routing based draft in the Spring working group. Maybe we can also take a look at that one and see whether something can be collaborated or inherited. The third thing is, I think you introduced a new identifier to identify a virtual network.
Yes.
And I'm not sure, maybe some existing identifiers can be reused or make some small extensions to meet this kind of requirement.
Yeah, that's for the T's work. I had that same thing, like, do we want to invest the AII? And I thought, well, that's a question for the T's guys, definitely. That's not anything I can decide.
Yes. No, in our draft, there is nothing extensions, right? I think it is more general, include just like the tier says. It's more general and requirements. Okay, problem. It's a problem. Sorry. So I think I will do the presentation on the TE's working group first, and then collect the feedback.
Okay.
And sorry for the third question. You say yes. I know we have discussed. I know your draft. Your solution. You use multi-topology. Yes, but I think it is conflict to interdomain. So like interdomain virtual network. But so we defined a new AII identifier of the virtual net to identify the network.
Let's take this discussion to the T's network
Okay, maybe last one is I think you mentioned use the AI as a constraint in the SR policy, right? And but the SR policy will usually be instantiated on the head end. Do you also consider those supported like loose path computation by the transit nodes? In that case, how do you build that information to the transit node? It's maybe not that clear in the current draft.
Yes, I will update it.
Yeah,
Thank you.
I don't know about across domains, but there is a proposal, and that's why it was put in LSR. The proposal is to add it to the OSPF and ISIS-TE information.
Okay.
Per link. Okay.
Thank you.
Thank you.
Pawan Biram, TCR. Yeah, we have already met in this session, so you don't need to wait till the next session to present it. So you can start a thread to initiate discussion on it. Yeah, I mean, at this point, anything to do with topology slicing, reservation within a slice, slice identifier, steering into a slice, we would like to discuss that in T's first, and then based on the solutions, we can take it to other groups. Thanks.
Sandy.
Sandy Zhang, IETF, just some clarification. The AII defined in this document is not a conflict with the multi-domain identifier. So it's two dimension to use for the path calculation. And we think that the AI is easy to mapping for interdomain use case. So we don't think there are any confliction in it. So we can find that they can work together and make the virtual network easy to deploy. Yeah, thank you.
Thank you.
It's okay. Thank you.
Thanks. So Sue, yeah, Tony, we're gonna have Sue go before because we figured we might get more discussion or whatever. No, I didn't want to phrase it that way.
Okay.
No, not that either.
Not either. I won't go.
Hang on 1 second. Let me get your slides.
Okay. This, while he puts up the slides, this is not a solution. This is a problem. So, so one of the things,
Uh-oh.
You got it?
Yeah.
Not in the right place?
No, this will just be one of those that we don't have.
She doesn't have the clicker though. Anyway.
Well, it doesn't matter.
Oh, it doesn't work.
No, I mean, yeah,
There it goes.
the clicker won't work.
Oh.
She doesn't have it.
Well, then I'm sure you guys will help me out.
Yep.
Okay. This is about looking at fast convergence for IP RAN grid ring topologies. There are many types of IP RAN topologies, so I've denoted that grid ring topologies. Now, this is basically research. This is not a deployed network. This is just looking at a problem that was reported in various places to the company, and so they asked me to look at it theoretically, and another set of people were doing a fast SPF calculation, and we were trying to put initial data together to just look at the problems that were reported and the actual theoretical piece. I am not presenting, the theoretics are based on work coming from Genghis Alusnov and people at Packet Design starting in 1995, so this is old equations, but I've dusted them off. Now, Tony made a good point on the draft in that I'm looking always in worst case, because this is a backend for a phone network, and you are looking for worst case convergence time so that if the phone is going to drop, we'll know. Okay, now you can go on. So what makes IP RAN topologies in the ring hub unique? This is a sort of global design. Please look at I guess it didn't turn out so nice on the screen. Please look at the slides. Essentially what I have is a very small grid. That's essentially 2 by 3.
One question. Are the cell sites on the top or the bottom?
The bottom is the 2-ring topology, and the cell sites are off the ring topology, and the rings are sonnets. Yeah. So the ring topology, we don't have the pointer.
Yeah, don't put it at your eye though.
Okay. I apologize. I should have made this again. The ring down here is a pretty standard sonnet ring. It connects in 2 places, so that's doubly homed. But sonnet rings have pretty normal failure characteristics. It can break in one place, and maybe you can use rotating rings and go back. But it has a limited set of failure techniques. It'll break in half, it won't return, but because it has two endpoints. Now, in most of the study, since the ring convergence time is based on these simple breaking patterns, that didn't become as interesting as some of the rest. I go into that, but I've got limited time. The interesting piece in the research, oh, you have to go forward now, is to look at the graph. Why is that interesting? Well, the RAN technology that I was asked to look at has power backup, so it sits in many strange locations, maybe northern Michigan where we lose power, or other places in the country. And it has power for the RAN radios, but it may get to these back rings that are connected, and you may have rolling power blackouts. Why is this different than data centers or current provider networks? You don't usually use multiple links. All your fast reroute calculations, and I talked to Aaliyah, the basic fast reroute and maybe the multi-link fast reroute only look at one or two. When you get to 3 or 4 in this grid, you're pretty distracted, and if it comes and goes, it's even worse. So let's look at a 9 by 12 grid to sort of do that. I need to go back one slide, please. My problem. Realize that in a grid, and that's the thing I'll point out, in the grid, the thing that has the most connectivity is the center node. If you then go to the grid in the next step, go ahead, now you can go to the slide. Yep. Does this work? It looks like
No, it doesn't.
Okay.
I'm trying to watch your hand. As you
No,
click
that's
it.
fine. No, that's well, you were doing pretty good. A 9 by 9 grid, if you sort of took the squares, it would look like this, where you have the center connectivity of those 3 by 3 grids. So just place that basic topology together. Okay. So what's the problems? As I mentioned, the sonnet, the rings with the routers, usually sonnet rings, connect to 2 grid routers, and the mobile RAN nodes hang off the routers. The grid size may vary. It may be 20 by 20 in some places, 10K by 10K, or even they'd love to have it bigger in 5G networks. You know, let's put the grid over the top of all of northern Michigan, and life is good, or remote Britain or some other remote places. You desire a single IGP, but you'd like a fast convergence, right? You want to have a limit of 200 milliseconds per as a goal. And Genghis, I hope you don't mind me referring to your early work. The equations are there and modified. My terminology might be centered, and I'm sure Genghis can send you pointers to his original talk. The rolling power outage has the problem. I think I've gone through that. Okay, what's the desired? Well, you'd like zero configuration, and Yakov Heinz has talked about that for data centers, but this is a different type of environment, same desire. You want a fast IGP, and you want the IGP to be one of the fast algorithms where it is used only after initial IGP convergence, and it must handle the fast. So this really provides a different set of topologies. Tony kindly ran his algorithm to see what improvement on this type of topology, and it's only 17%. That's probably minimal. It's not built for this. It's not dense. This is so. What the purpose of all of this that I get is I just provided the equation. I wanted to talk about the problem, and I wanted to know if the group is willing to look at these type of topologies. They are not fast. They are not large data centers. Yes.
Hi. Sorry. My name is Uma from Huawei.
Yeah.
So you said that the topic title is IP RAN topology, and you talked about a lot of SONET, and you also mentioned 5G, but 5G RAN is all layer 2 network.
Yes, I realize. I know. I tried to say IP RAN grid and hub, and I should have said not 5G. Okay. Right. These are existing older networks.
There's another thing that messed me up was you talked about a ring and then you showed a grid.
Oh, I'm sorry. I talked about a ring. You have to go back to the beginning. the topology is both rings attached to a grid. So all of those rings will hang off a grid. And I put it in my slides.
So
I should have been. Did
it's
I
kinda
forget
hard to see.
anything?
You could-
Other caveats I should have cut out as far as the 5G stuff?
So this problem is applicable, but it's RAN. If you put layer 2 stuff, I think that's more convincing actually.
Yeah, it might be.
Yeah,
I just was staying with the IP stuff.
Yeah.
You're welcome. I'm raising the topic because I asked the question on the list.
Yeah.
Maybe you can help me contribute
Sure.
some better layer 2 or work with me on the draft so we can tell people what convergence.
Other question is fast reroute for multiple failures, right? That is never done. I think maybe it is good to separate that problem in routing.
Absolutely.
Working better.
You should do the simple first, fast, any type of fast convergence.
FRR. I'm talking about FRR. I'm talking about FRR, fast reroute if multiple failures.
Let me. I agree, but
Your blackout case.
Blackout case. Let me just go it in several cases. You want to get any type of algorithm without fast reroute that can improve the convergence in general. Then you might want to add fast reroute, and only when you get all of that done would you want to do the multiple link, because it's tough stuff that you have to have the other stuff done ready for. Any questions on the problem? And my question asked for the group, is this appropriate for us to bring the problem and the fast convergence?
So just to close on my point is, if you separate the fast reroute problem, there are other domains where that can benefit blackout kind of scenarios where multiple failures can happen because of the power failure or something like that. Yeah.
Thank you for adding it. That's not something I researched, so I'm glad to hear that.
Yeah. I'll just say, speaking as a working group member, I don't think it would be bad. It's not like our list has so much traffic to start an email thread on it and let people brainstorm. I don't want to do it here right in this meeting, but we could, because as you're saying that, I have all sorts of questions on it. I say, no, I'm not going to say anything more.
Right. I'll start a topic. This was just to introduce it. If you object, please tell the chair so we can take it someplace else. But we'd like to continue to talk about the topic.
Now.
Thanks, Sue.
Yeah. Is this going to work?
As long as I think the key is if we got it as PDF, it works. And if we go to PPT.
Hi, I'm Tony. This is not my first IETF. Yeah, 40th is probably closer.
It's the good one.
More than 40 if there's 3 a year.
Yeah, but I missed a bunch. Pocket.
Okay. Yeah.
All right. So today's first talk is about hierarchical ISIS. Actually, I gave this talk in Bangalore. I have absolutely no changes. That's because I got absolutely no comments until this Monday. I got a long list of bugs.
Bangkok.
Yeah, no changes since Bangkok. Okay. The point of this, I'm not going to go through all of these unless people really want to, but the basic idea here, ISIS today has 2 levels. We could have many more very simply. It's a lot of code point allocation, but there's nothing really complicated about it. We can just basically dial it up and go all the way to 8 levels without a problem. Now, I did get a set of bug reports. Les Ginsberg and Paul Wells have found lots of mistakes that I made in the details. I am going to fix all of those. They've offered to contribute text, so we're going to do a lot of changes. So I guess the outstanding question, do people have other details that they want to discuss, and do they have a conceptual problem with doing this?
So I think I've asked before, but I didn't. I scanned the draft. I don't see an answer. The areas, how I think you have to specify how, at least talk about how you do, like, now that level 2 will have an area that has to subsume the level 1 areas, how does that interact? How do you divide the NET up, and so forth and so on? Like a whole section on that would be good.
Thank you. Yeah, so one of the obvious things right now is that we have an NET, and you should be able to have common parts of the NET at various different levels, and there's no obvious way to say how that should be divided up. The obvious thing you could do is to have that be a per implementation configuration, and you have to agree on that configuration between two systems before they actually would join. Now, one of the comments that Les and Paul made was that that's really, really hard, given that almost nobody in the room knows what an NSAP is.
Wait a minute. This is ISIS.
I said almost.
I know what it is, but I never met one that I liked.
Well, that's true for all of us. So one of the proposals that Les and Paul have given us is that we actually have some kind of area identifier and add that on. And yes, we will discuss how to do that once we have a proposal on the table. Okay. Any other questions or comments?
Hello, Julius Kroberczek. I've only just discovered the draft right now, so it's probably going to be a stupid question. You'll forgive me. I've heard of a thing called BGP that's used for interconnecting ISIS networks.
Really? I've never heard of that.
So what's the reason why that's not suitable for the kind of networks you're considering?
So BGP, at least as it was originally intended, not how it's been abused, was meant to interconnect domains, okay, separate management. What we are trying to do is to scale up ISIS so that we can build ever larger networks under the same management. Okay? BGP and policy should not be necessary within a single administrative domain.
So you are saying that from an operations point of view, it's a simpler solution?
Far simpler.
Okay.
There's a massive amount of configuration required for BGP.
Okay, that makes sense. Thanks.
Other questions?
Hey, Tony, I think what may be obvious should be stated in the backward compatibility. So you really, for areas beyond, how do you, level 2 is the place where it gets a little confusing, because a router that doesn't support multi-levels could be in level 2. And I know above level 2, because there's new PDUs, it doesn't, you don't have to worry about backward compatibility. They support it or don't. Are there any considerations that need to be put in there?
So if we've done things right, there should not be any interactions with existing L1 and L2 routers that cause any interoperability issues. Okay. One of the things that Les pointed out was that there were some bugs in that area, and after we fix them the way that Les proposes, I believe we will be at a situation where we have no intersecting PDUs. Okay. Tony P.
Juniper, is there any interest at the next IETF to do like a 10-15 minutes something PNI lessons learned to save some red hole explorations?
Well, we're building the agenda right now.
Well,
yeah. I think we'll have time for it.
Is that a no? It's a nice way.
No, it would be, especially, you look at this, it looks like a simple extension, but it has to be more than that. That's why it'll be interesting, being someone that only impersonates an ISIS expert. Yeah, I think that would be good from my perspective. What do you think, Chris? Sure.
Especially if we could do 4 hours again, because This is turning out to be the great session.
I'm old and hard of hearing.
I was just saying, if we do another 4 hours where we have loosey-goosey second day, that's perfect.
It's a good time filler, he says.
Yeah.
Because it makes for a fun discussion.
Good. All right.
And we only had one Yang model, and that was my fault.
All right, cool. So I see whether I cook up something 10, 15 minutes. Would need to reread a lot of stuff.
Rajiv Basari. Just think, I've had the pain and pleasure of architecting some of the large-scale networks on the planet. You know, the definition of large scale is more than 100,000 routers. So when I think about the problem that I ran into, this rings bell. Because the sane approaches that get used to build a network is a lot of hierarchy. And when we think from hundreds of thousands of routers perspective, you got level 2, you got lots of level 1 to delineate, but after a point, scale becomes, and convergence that goes with it, become the most foundational roadblocks to extend level 1. So the question I had while saying that, yes, it does sort of ring a bell in terms of having to, it would be nice to extend ISS all the way to the end across the same level 2 and level 1 across hundreds of thousands of routers, and many, well, at least one of the networks has 200,000 routers, more than them. Is the notion here that we can, go at greater scale with another level?
Well, right now, there is some upper bound on what we can manage to fit inside of one area. In the early 90s, the conventional rule of thumb was about 1,000 routers. I don't want to mumble something because as soon as somebody hears a number, they will go off and sue me if their implementation can't handle a bigger number. But even using that 1,000 routers, okay, if we have a 8-level hierarchy, then that's 10 to the 3rd to the 8th, which is 10 to the 24th, which is a whole lot of routers. Okay. So yeah, I mean, the idea is to be able to scale, right? That's the whole point of this, is we are up against the point where some people, if they were using ISIS, would be bumping up on today's existing limitations. And I want to relieve that before they get to those limits in practicality.
That would make sense. And so I think what I'm taking away is that the notion here is to address scale, large scale, with reasonable convergence in the mix.
Of course.
Thank you.
Other questions? Okay.
You want to do some polling? Ask people if they've read the draft. How many people have read the draft? Good. That's better than about half. How many people would like to leverage multi-level ISIS networks for more scalability? A few more, okay. Yeah.
So ask how many operators just raise their hand.
How many operators? Good question. That's why I wanted you to do one.
Okay.
Okay.
Yeah, okay. But there is interest. Did you have one more slide, Tony? Were you going to?
I have a ton more slides here, but I don't want to go through them.
On the hierarchy.
And bore people. Yeah, they're all boring.
Okay, well, so I thought you were just going to get to one where you asked for adoption.
Yes, we want working group adoption, but given that we're about to overhaul the document, it would be premature. And so I will pend a deferred request for working group adoption after the next revision.
Okay, yeah, and it does seem like there's plenty of interest in the room. I think everybody's kind of wanted to do this.
You almost have me at the edge here. I'm waiting for the next slide.
Okay, the next slide. Levels 3 through 8, fix the circuit type. New bits, there's the values. New LAN hello PDUs, more LSPs, more CSNPs, and that's it. Okay. All right. Very short discussion. Okay.
So, I mean, have you run simulations on this? I knew you were doing simulations on the other stuff.
No, I have not.
Yeah, because I'm curious about, like, I was just talking to Les recently about how it's sort of annoying to have to do an adjacency database on lands for every level, and then you collapse them for the point-to-point. Did you get into a permutation combination thing with the point-to-point?
I don't think there's a serious problem given that we're going to have to go to separate PDUs per level.
Oh, you're going to do that on point-to-point?
Yeah,
Okay.
there are some problems doing it the other way. I was trying to conserve PDUs, but it turns out it's a bug.
Okay.
All right. So the next talk is about area abstraction. This is a talk that I tried to give in Bangkok, and I think I kind of muffed it, and I would like to try again. So this is a new slide deck, all the same concepts. All right. So suppose we have this large scalable ISIS network, and this is only 60 routers. The circles represent level 1 areas, and of course the WAN is level 2. Now, in a traditional ISIS network, we're going to have to run a bunch of things here as being L1, L2. And we'll talk about exactly why in just a second. But what is going to end up happening is that the level 2 link state database is not going to be tiny. We would like it to be tiny because, of course, we would like it to scale. So how can we actually do a better job of abstraction? If we have an ISIS level 1 area today, and we want to have transit of that level 1 area, we have a small problem. Take a look at the 2 yellow paths highlighted here. If we want level 2 traffic to transit that level 1 area, then all of the systems that we touch with those paths have to be L1, L2 systems. So all of those.
Just to correct, I might be colorblind, but those are, I see green. Are those the?
Okay.
I figured somebody was.
I am colorblind. If that's green, I apologize.
Okay.
So the point is that we have to put all of those LSPs into level 2. And that's sort of unnecessary because, frankly, they're already in level 1. As you can see, if we use all of the possible paths, all of the nodes within this level 1 area end up becoming L1, L2. Okay? This is not buying us anything from the point of being scalable. So what do we really like to do? Well, it'd be far better if we could just model that entire L1 area as a single big router at level 2. We'd like it to be a single LSP. How can we do that? Okay, well, there's some simple things we have to do. A level 2 router has to send out a system ID in its IAHs, and we're going to have to send out a single system ID from all of our level 2 interfaces. Now, never mind the fact that we're sending it out from different routers, but this is kind of what we had to do to fake this out. We have to participate in level 2 flooding. So that means that LSPs that come in on the left-hand side have to exit on the right-hand side, and vice versa. We have to generate a level 2 LSP that looks like we have all of these adjacencies. And for scalability purposes, we don't want to inject anything into level 2 unless we have to. So really, it should just be this one LSP. And oh, by the way, yes, we have to forward traffic. So the level 2 transit traffic somehow has to transit our level 1 area. And some of the things inside that level 1 area may only be L1 routers. So how do they handle traffic that they may not have a prefix for? Okay, well, to attack the first problem, what we're proposing is that we're going to add a proxy system ID. Right? When you're busy configuring your system and you're configuring your network and you are assigning system IDs to everything, you now just add one system ID for your level 1 area. This gets advertised by the area leader, and all of our level 1 edge routers are going to see this. This gets picked up by all of our edge routers. The L1, L2, they're going to be L1, L2 routers, and they're going to use this to generate their L2 IAHs on their level 2 circuits. Okay, we need to provide level 2 flooding across our level 1 area. Now, if we have a direct connection to our area leader, and the area leader does need to be L1, L2, well, that's a good thing. We can just make that circuit level L2 and we'll be done. But there may be some L1 only routers in there. And if we want to do that, we have to tunnel across them. So we're proposing that you tunnel from the edge router back to the area leader. Once we've done that, we now have a full-blown flooding topology that we can actually run our link state on. Any questions there?
Yeah. Why don't you, rather than tunneling to the area leader, why don't you do a full mesh of tunnels?
See flooding, dynamic flooding problem?
Well, no.
Full mesh?
Yeah, okay, I don't know, I guess. Where does the data traffic go? I guess you're getting to that.
Data traffic to come in a future slide. One moment. Okay. Waymo.
Yeah, Waymo from Huawei. I think this is an interesting topic. And we had a group of people working on for a long time. Yeah, that's a TTZ. So we have
He's got that in a later slide.
Yeah, we have several options. And then we virtualized one group of node as one node is one option. And then we also have another option, which is AC mentioned that we have a full mesh of edge node. So I think maybe we can maybe have discussion, whatever, merge, whatever, if we want to move this forward.
Please hold that for about 3 slides.
Okay.
Okay. All right. So now we need to generate an LSP that represents our level 1 area into level 2. So the way this happens is pretty straightforward. Our area leader now has a working level 1 link state database and a working level 2 link state database. And from the level 2 link state database, our area leader can see all of the external adjacencies that the L1 area edge routers have. Okay, so who are all of my area neighbors? And from that, it can contrive to advertise all of those adjacencies as part of a proxy LSP. Right? We're going to fake out an LSP and that says that our proxy system ID is adjacent to routers A, B, C, all the way through H.
And those are all the area border routers in the level 1. Edge router.
To be more specific, those are the neighbors of the area border routers. Got it?
Okay, yeah.
Okay. Yep. All right. Now we are not going to flood all of the level 2 LSPs from within the area outwards. We're only going to flood out the proxy LSP. The L1, L2 edge routers can do this because they're expecting to see everything coming, only the source from the proxy system ID. Right? So they know not to do that. Anything that folks would normally leak into level 2, that can be done and shoved into the proxy LSP. Okay, so prefixes, summaries, anything that normally would be advertised can go into the proxy. All right, now the forwarding part. Suppose we've got transit traffic that arrives at our L1, L2 edge router. And that traffic is going to match some L2 prefix, so we know we've got to forward it. One of the things that we're going to have to do is to figure out a path that transits our level 1 area. And it would make sense that it would transit directly to an exit edge router. Now, because we're transiting level 1 routers that don't have a level 2 link state database, they don't have forwarding entries. So of course we have to tunnel across them. I'm specifically not trying to specify what the tunneling technology should be, because I know lots of people will choose different things. But the point is that when we're doing the level 2 SPF, we should insert forwarding table entries that point to tunnels to those exit routers. And yes, vendors, I do expect that people will make automatic tunnels for doing this. I don't think people should be forced to do static manual tunnels and somehow manually do all of this hacky stuff. All of that should just be generic. One of the important points here is that the level 2 SPF is going to see intra-area metrics. And yes, I'm stealing OSPF terminology here. I hope that's okay now that we're unified. We have to be careful about intra-area metrics, and we can only use them for path differentiation when we have inter-area metrics to the destination that are identical. And the reason for this is you don't ever want to accidentally have your metrics inside of your area force you to choose a path going back out of the incoming side of your area. You end up creating a forwarding loop instantly.
Next slide.
Okay. All right. So basically, if we do this now, we end up with a network where we've got 6 level 2 areas, and we've got an entire link state database that's only got 6 entries in it. That's a pretty scalable network.
2 questions, Tony. Actually, I didn't think your Bangkok talk was muffed at all. It was actually pretty clear. Okay. First of all, the first one is, are these topologies, where do you see them? Because in the service providers, usually there is the WAN routers, access routers, aggregation routers. There's a clear hierarchy. You don't come and then go to the other layer. And the data center is also pretty hierarchical, leaf spine, this, that. I mean, if it is very common, because there's a lot of stuff to do, right? If it is very common, this kind of topology is absolutely. But if it is like one-off or something, that's my first question. Where do you see them? How often do you see them? And so forth. And the second question is, all of your proposals are kind of addressing the same problem, scale. And I definitely like the first one. I'm scared of this one. It's definitely achievable, but, it's more scary, obviously. And are you asking us to favor one over the other, or do you actually need both of these?
I think both are useful. Okay. Yes, they are both attacking scale. But at the end of the day, I think we can use both. And what I'm trying to do is to give us tools. My history of attacking scale, you use every single tool at your disposal, because every single tool might give you an order of magnitude improvement.
Yes, I agree with that. However, maybe the first order of magnitude improvement you get from your first proposal may be sufficient for the next 20 years or whatever, right? I'm kind of, sometimes it's better to stage these as opposed to go at once. About my first question, where do you see this kind of topologies where you must actually go into a lower layer to come out at the other end?
This is intentionally topology agnostic.
Okay.
I'm not worried about use cases.
It's not based on a data center or a service provider. It's not based on.
Don't care. Don't care at all.
All right. I got that. Thank you.
Rafał Szarecki, Juniper. Is there any reason why L1 is ISIS L1 in this case? Can it be anything?
Well, I don't know how to spec anything, but other than that, yeah.
Oh, OSPF, Rift, I don't know, whatever gives me IP connectivity.
Yes, you could conceivably have OSPF inside of an area here and use this similar mechanism. Obviously,
because there's any interaction between these 2 layers, right?
There's some. Remember, that you're having to
default attach bits.
You're having to use L1 to distribute information, right? The proxy system ID is carried around in L1.
Oh, okay. Yeah, get it.
But with suitable amount of drafts, yes, you could hack that.
Yeah, but you said that you're flooding the L2 over the tunnels in L1, or if you need them, or directly. So that really wouldn't force you to have.
But this part is auto configuration part, so it comes before tunnels are formed. So this piece may be good to have flooded, but then we can try to extend OSPF. It's not tight. It's only one element.
Yes, there's ways you could do this with OSPF, no question.
You have experimental.
Jeff Oz, Tony, I'm not an IGP guy, so I have what's potentially a very stupid question.
I love stupid questions. They have easy answers. Please hit me.
So the whole idea here is we have we're putting this stuff into this summary proxy node. That part I sort of get, and I can sort of picture how that behaves if it was something that was BGP, for example. What happens if you partition your internal proxy node? It's like you got this L1 that it's meshy, it's all connected. If you cut it in half, you would effectively have two split brains that really aren't connected to each other. I thought IGPs didn't really like that.
You are absolutely correct. IGPs do not like it when an area partitions. Okay, they get indigestion. There have been some, shall we say, hacky proposals that people have used in the past to protect against that. Mm-hmm. Basically, you tunnel from one side of the partition to the other and tunnel through level 2.
It sounds like BGP.
Yes, you could do that, and I'm not saying we can't do that here, but I'm not trying to cover that.
Okay. So the draft doesn't talk about this as a sort of danger at all?
No, it doesn't.
Okay. Thank you.
David Lamparter. So I did look at a very similar thing several years ago for hiding a OSPF area from a mesh network. So the entire OSPF domain would appear as one mesh router to the mesh network, which is pretty much the same thing.
Well, OSPF already has a more primitive version of this with the virtual link. So yeah. it does this. It's a lot simpler in ISIS because in ISIS can only be attached to one level 1 area. So it gets rid of a lot of the weird corner cases where you're getting the same route through other level 1 areas plus the level 2.
So I know that the idea works is what I'm trying to say. But I do have at least two questions. The first one is, did you actually look at how much you're saving in flooding overhead by having this special role of the one system that is responsible for managing the LSPs? Because I think you can do the entire system without such a special node, and I'm not convinced that the reduced flooding overhead is worth the extra hassle at this point.
Another thing you could do is, because it's somewhat proven and it is simpler, most of the bugs with the virtual links are due to these having AS externals come in the different areas, or having to look at the summaries in different areas. You could, depending on how much it is, I'm not trying to change your draft, you could just leak the L2 summaries and L2 not the topology, just the prefixes down into level 1, and then just use routing, and that handles partitions automatically. It handles everything.
Yep. So that is also what I did for the mesh thing, by the way. We just redistributed down from the mesh into OSPF, but not back up. So right. Yeah. And the other question I have is, you mentioned this.
Wait, I wanted to hear the answer to that question.
Sorry?
I wanted to hear the answer to your first question.
Oh, sorry.
So yeah, I of course thought about it. The clear problem we have way back here on slide 1 is that if we just keep carrying on building arbitrarily large networks like this, our level 2 is going to explode. Okay, and so we have to do something. Okay.
So so if you start hiding a particular L2 subset, the only thing that concerns you for the flooding overhead inside of that is the number of members of that subscope. So are you expecting that to become arbitrarily large as well?
Yes, I expect everything to become arbitrarily large. That's the secret to scaling.
Okay. So I would still like to see some actual data, or maybe like trying to hack at it and see how much the flooding overhead is before I would be convinced that this is the best approach.
Okay, well, we already can show networks where people have given up on IGPs because the IGPs cannot handle the flooding. And if you take a look at dynamic flooding, that's exactly what we're trying to solve there. And we've got a ways to go there. So we've got problems. We've got real scaling problems.
Okay, so the other question I have is in this topology hiding thing. So I would need to look at the details, but this is a pretty large change. Wouldn't you want to make this something to be considered for the new, like, level 3 and up, and just leave level 1 and 2 as they are, and just for making things easier in terms of interop?
I'm not scared of changing this in level 2, no.
Okay, I am.
Okay.
So, well.
Level 3 is going to be a ways out too, and that's going to take us some time. So.
John Scudder. This is fun. Thank you. I'm not sure if it's useful, but it's definitely fun.
Thank you.
So I had two things. I had one when I stood up, but then you and Jeff had a little conversation and talked about partitioning one of the L1s, and I expected the conversation to go somewhere different. So each one of those L1s you're modeling at L2 as a router.
Yes.
And it is not a common failure mode for a router to fall into two pieces and have the two pieces both start behaving like routers.
And behaving like themselves.
So. Right, behaving like two clones. Yeah.
Yes.
So, and I was, waiting to hear you say, oh yeah, I'm going to fix that with the area leader, and one half is going to have the area leader in it, and that'll be the router, and one half isn't, and that one will just shoot itself. But you didn't say that, so I'm giving you another chance. I mean, is there something along those lines, or is that just like TBD?
Mostly it's TBD.
Okay.
I know a lot of people who had an area partition would be upset, and they would prefer to see a hacky tunnel rather than having half an area shoot itself.
Yeah.
We can have that argument.
Okay. Yeah. Would you like bad, or would you like worse? Yeah, or would you like one half to rename itself as a different, L2 router?
Actually, what I'd like to do is adjudicate it and say that areas can never partition, and we don't have to worry about it. I don't think anybody's going to let me get away with that.
Yeah, sorry. The second thing, I'm the one that got up for to begin with, and I assume that either I just missed this, or like I took my eyes off the coconut shell at the wrong time. I get how you originate your LSP from outside of one of these things, your fake LSP. I get how you have forwarding connectivity across it. That's straightforward. How do you flood across it?
Okay, so the hack here is basically flood everything through the area leader, who's going to be an L1, L2 node. Okay, and the way to do that, if you don't have a direct connection, then go ahead and tunnel across to the area leader.
So I'm modeling my internal stuff as L1, L2, but I'm going to quietly not expose that externally.
Yes, exactly.
Okay, thank you.
Okay. All right, any other questions so far? All right. To Huimo's question. So Huimo already published a document called Topology Transparent Zones. This was completely independent. I had no idea that he had previously published this. We turn out to have very similar goals, almost the same results. Different mechanisms, but the same end. So the differences that I could see, and this could subject to my reading. Zone boundaries don't necessarily coincide with area boundaries. In Waymo's draft, all of the zone edge routers add an LSP to the level 2 link state database. And then each of those edge routers has an LSP that links to the other edge on the other side of that same zone. To me, that's something of a concern for scalability, because now all of your edge routers do show up in the external L2 link state database. Mr. T.
No, keep on.
Okay. Let's see, they've got a smooth migration mechanism. So this actually can turn itself on and off gently. And that seems like that might be very valuable. So I was going to propose that we combine drafts. And since your draft precedes mine, I think we should combine into yours. So we should talk privately.
Okay, Tony P. Juniper. So is TTZ an RFC already?
No, it's still a draft.
Okay. I think philosophically, they pursue this.
Wait just 1 second to clarify, the OSPF was made into an experimental RFC.
Right, yeah, that's what I remember, right? Yeah. Which is whatever, just beside the point. We can always piece things, right? It's popular these days. No, I think there is a big philosophical difference. They do not try to make this thing look like a single router, right? And I think that is...
yes, that is one thing that we need to resolve.
So that's something you would have to kind of settle on.
Yep.
Okay.
Rajiv, go back to your previous slide, please. Not this one, the one before that has, maybe it's the first or second slide that you had all of these different routers connecting, interconnecting. One more. Okay, thank you. Is an assumption here that the smaller blue boxes that we have, or for that matter, the rectangular boxes that you have, do not need to communicate with the similar box on the other side of the network?
So the square boxes in here are L1 only routers. Okay, so they do not have visibility outside of their area or communications. And obviously, there could be a lot more complicated topology there than what I've shown. But the point is to allow those things to exist.
So in this case, all the circles, they have any-to-any reachability. Is that the right takeaway?
Well, everything has any-to-any reachability. Okay, reachability is still there. The question is, what is in the link state database? Okay, the square boxes, because they're L1 only, are going to see area border routers. And they're going to pick default pointing outwards. And those L1, L2 boxes, then, because they have L2 information, presumably are going to be able to forward.
Thank you.
Okay.
The get fly again. So if you start to think about exactly this manageability aspect, it becomes pretty soon what AC said. And I kind of agree with, right? The TTZ was justified because they really wanted to carve out something which was not an area boundary, right? And made it very hard to do anything else. But if you leak the prefixes, it doesn't work with the default, right? Like with the attach and the default, that doesn't work. It will black hole. But if you just carry the prefixes around, you can afford the prefix scale and you just leak the stuff in.
Okay.
Hi, Alvaro Retana, speaking as myself.
Okay.
I'm one of the authors of the TTC work. So yes, you're right. We have similar but slightly different objectives. I think that we're especially proud of that migration mechanism, which we thought was relatively smooth. So I mean, obviously, I think the right thing to do is to work together on this. There's no point in having two similar solutions. So yeah, let's talk offline and figure out how to move this forward and how we make it better.
Cool.
Thanks.
Thank you.
It's Peter Pshenak, Cisco. So it has been mentioned here that this resembles the virtual links in OSPF. And I remember that the virtual links in OSPF has actually only the one use case to fix the bad design. It looks to me we are trying to create some hierarchy where the hierarchy hasn't been imposed from the beginning. I'm not sure this is what we want to do.
Yes, we are trying to fix the hierarchy that was not optimal when 10.589 came out. That is the whole goal. This may not be the perfect solution, but
Go ahead. Finish.
Well, we're trying to get somewhere. So,
hey, Tony, I didn't really from the draft. I didn't understand the subtle details of this one until today from reading the draft. I don't know if there's something missing or I just read it too fast or something, like some of them.
Typically, my writing is overly cryptic. So if I understated something, I apologize. Please comment.
So AC, I will give you another example, not having played in ITPs for a while. I actually thought his writing was crystal clear and easy to understand and where he was going. So I'm not sure you should change anything.
So okay. So I'll try this again. Maybe this today will work better. From a chair standpoint, we decided not to do TTZ. This was before we merged groups, so this is sort of an interesting thing because OSPF published an experimental RFC and ISIS basically let the draft expire. I would be interested in hearing what changed. I'm not saying that, there definitely could be things, right? But why as a working group prior did we feel that TTZ wasn't needed and why do we need it now? So that's just something to consider. I'm not actually looking for an answer right now, but I think it's important to maybe address that.
Well, I can address it a little bit. For my part, I'm interested because my boss came to me with a gun held to my head and a customer in his hand and said, "Fix this, Tony."
Fair enough.
Yeah. I looked. Maybe it's because I was familiar with others. What I didn't immediately glean out of it was that the area border routers or the layer 1, 2 routers didn't look like that at all. You didn't know that you only saw them as layer 2 routers out on the edges completely. Yeah.
I'd be happy to add clarifying text.
You only saw one big. You actually did see one big router like that. That's what I didn't. That's what I didn't get until today.
Okay. I will add some text.
Okay.
Thank you.
Yeah, Cengiz Alaaddinoğlu, Blue Planet. Actually, my view didn't change. It's the same. And basically, virtual links, OSPF, we have about 600 deployments. I have not run into it yet. I am sure it's out there someplace, but service providers typically do not like complicated stuff. I like the multiple levels because, it's the same thing, but we know is generalizes it. It doesn't change anything. It's the same rules. It's just, multiple layers. This one is complicated. I'm pretty sure the initial implementations will be buggy. Eventually we'll get it right. I don't doubt that, but it would be really nice to hear from either service providers or data centers, wherever these networks happen, to hear from them whether they are willing to deploy this. But after the GAN, did you come up with 2 solutions to the same problem, or you needed actually both of these solutions? That goes back to my original question, because your first solution probably gets rid of that GAN, does it, or no?
No, it doesn't.
Okay, so you do actually have a topology where you must go down a level and then come up a level.
So I was going to mention this, Tony. You said that you didn't want to do anything specific, but I thought I read in the draft that you have a specific example of a class with the L2 at the.
Yes, I want to support that, but it is not specific. The idea here is that we have to be able to be more general.
It might have been what Cengiz was looking for, though.
Okay.
Robert Rashuk. So I have a question here. So if the L1s are really only pointing default out to the ABRs, it works typically quite well when the L1 is stop, not when the L1 is transit. So don't you afraid about suboptimal exits being taken for the originated traffic within the L1s?
Yes, but that's orthogonal to this work completely.
Well, if not, if you put all the routes everywhere, right?
Well, but that's a scalability problem, right?
But isn't Robert's comment, isn't that a network design issue?
Absolutely, and that exists today. Right? Somebody who's only got default is only going to point to default, and that may not be optimal. Optimality and abstraction, we know, are not good friends.
Good idea, right?
Any other comments or questions? Cool. Thank you very much.
Maybe one quick one. So what scale did you end up with? Like how many boxes in that specific ask that you had to address?
I'm sorry, I don't understand the question.
Oh, you said you had somebody who asked to get this developed. So clearly there was a scale in mind, number of nodes that needed to be served.
That particular customer wants to own the entire world.
Okay, you answered it. Thank you.
Okay, I have one more quick one. I don't see any reason you couldn't apply this recursively, right?
As in having this apply level 3 over level 2? Yes, of course.
No, as in take that whole thing and draw a big circle around it and then build a topology out of those, yeah.
Yes. The point is for these two to work together.
Thank you.
Anything else? All done. Thank you.
Yeah, that's good. Thanks, Tony. Yeah. Keep us updated on your discussions with Alvaro and Wemo as well. Thanks.
Okay, I think that was it. Let me reiterate what AC said last time, which is we really don't want to waste any time. So we're going to try to get our agenda set up early before the next IETF. So send your requests early. But as Tony P asked, it can be interesting things to talk about. It doesn't just have to be silly TLVs.
You got your first topic already.
Yeah.
Thanks, everybody.
Oh, that was so much more enjoyable than this. I don't know. They were all interesting. Hi, Rad. Oh. Okay. Yes. Okay. No, I think it's good to do it in T's. You know, this whole enhanced VPN stuff. I haven't been following it, but I know that splicing is a problem that a lot of people are trying to solve in the IETF. I'm just not one of them. So. Anyway. Yeah. It's good. Is this have you been to the IETF for other working groups before? This isn't your first IETF, no. Yeah, that's what I thought. Yeah. Yeah.